So my next question is, otherwise my I would say maybe offline or online. I would like you guys to install GitHub, STS, Maven, and mostly or firstly Java. So this is just a list of softwares you need so that we'll start with your our lab sessions as well. Java, GitHub, STS, and Maven. So if you need any help installing these softwares, you can just post your question on chat. I'll try to help you. So mostly the plan is like every day we'll have our discussion for 30 to 40 minutes. Then we'll try to have a lab session for 20 minutes at least. Sometimes maybe alternate days, completely lab session and complete discussion, depending on the topic. So, and my plan is, uh, you know, I would maybe I'll ask any of you guys to share your screen so that so that we'll cover each of your system and see how it is going. Maybe if you have anything not updated or anything if you have any gaps in doing labs and all. So we'll just try to each day we'll try to pick up one of your screen and we'll try to work on your screens and mostly the procedure is I would keep uh, checking in partially completed programs to my GitHub, my public GitHub repository. I'll keep sharing you the link, the GitHub repository link. On each day, you need to, for your labs at least, you may need to git clone the partially completed programs and enhance the program with let's say today we have discussed something on Spring Boot. So maybe you need to enhance the program using Spring Boot annotations, and you need to you would be able to run the program. Sometimes my programs may contain just test cases, unit test cases. So based on the unit test cases, you may need to write the program, the actual program to uh, you know to get your test case passed. That is something I'm trying to follow test driven development kind of approach. So that's how we plan mostly the labs. So but for now I have issue in JBoss configuration. JBoss, I have not asked for JBoss within Java, GitHub, STS, or Maven is fine for now. If you're looking for something on JBoss, yeah, we'll definitely see it.
Okay, sure. Thanks.
So mostly you would be having any Java latest version is fine. Srinivas. So mostly we'll be having Java STS. STS is Spring Tool suite. Those guys who doesn't have Spring experience or might be who are using legacy IDEs like Eclipse and all. So we can start jumping onto or install Spring Tool suite. It's almost similar to the Eclipse. So you won't feel much tough when you start using STS. So STS is something you need to install a zip folder and you need to unzip and you can just start STS there. And Maven, of course, so you'll find an installer on it. You can just install it and make it onto your class path so that you'll be able to execute Maven commands from wherever you are on your command line. So for now, with Java, GitHub, STS, Maven, those are the things you can make it offline as well. So after this session. That's fine. 3.5.4 Apache Maven. Okay, I'm sharing my screen. So far, ideally, I didn't have anything to share in the discussion that happened so far. So I'll let's jump onto our topics and continue from there. STS, the one I have on my system is 3.9.6. Srinivas, was that Srinivas? Yeah, STS means Spring Tool Suite. So it's actually, I just explained. It's an IDE. So if you know Eclipse, it's a similar kind of stuff, but with lots of inbuilt functionalities compared to Eclipse, and mainly on Spring-based inbuilt functionalities. You can just straight away use uh, in STS. The Spring Tool Suite. So anyway, I have shared my screen. I think you lost my screen again. I shared it again. Okay, so can I get a quick nose from those who have not attended the demo for this microservices? You can just type no and enter so that I'll see the number of no's. And Ahmad, I guess it was you replied saying you're not attended DevOps demo. This is not this training is basically on microservices. So just wanted to make it clear. Uh, Microservices with Java. So we may not be covering DevOps in detail, but we have something on Kubernetes and all, continuous delivery also, continuous development, continuous delivery. So we are going to see few basic topics of DevOps, but this is not in-depth DevOps training. This is an in-depth microservices training with Java. Okay, so I see multiple nodes, at least 6 people. So microservices you have not attended. Right. Right, I see a pretty good number of people that haven't attended demo. So for that reason, I would like to just reiterate the topics or the syllabus that we are going to cover as part of this training. So there is actually a set of prerequisites for this training. So I expect you guys are familiar with the Java programming and also at least little bit Spring knowledge. So those who doesn't have Spring knowledge, can you can just send quick notes, no Spring knowledge at all. So I take it as everyone knows Spring. I have not received any no's. Okay, that's wonderful. So many people started working on Spring, right? Anyhow, Spring is very old technology. By the time maybe every Java developer, already got jumped onto the Spring. Not much knowledge from Srinivas. Now just like 10%, little knowledge from Srinivas P again. Okay, right. So I should be taking it as at least 60% of this group doesn't have Spring knowledge, right? At least I've received from 6 people. No problem. Well, I'll try to touch base basic details as well whenever we come across some Spring related stuff. That's fine. So knowledge on Java programming is definitely, I guess, 100% we have from this group. If anyone doesn't have, maybe can send a quick no. So Java, 100% of this group has knowledge. Spring, roughly 30-40%. So 60% people still, few people know it, few people didn't implement, few people only 10%, few people not at all aware of Spring. Okay, that's fine. So that gives me like Spring topics also need to be explained, at least some core topics. That's fine. We'll try to cover. So that's about prerequisites, Java programming and Spring. So I got an idea of how you guys uh, are, currently maybe, or currently equipped with little, different technologies. That's fine. Maybe you might be working on something different, so that's fine. But still, yeah, Spring is, we'll just keep it in mind. We'll try to cover the basics. So then, this session basically starts with introducing microservices. So we'll try to understand what's the concept of microservice. That actually, to understand the concept of microservice, we need to understand what is there in the current market. What is the legacy environment or legacy way of developing the application? What is new in microservices? The classic way of developing any software application compared to the microservice. So that's how we'll try to understand the microservice concepts, and we'll try to understand more on microservice concepts by comparing different benefits of microservices with different drawbacks of existing three-tier, traditional three-tier, two-tier architecture, or in short, we can call monolithic architecture. So that's how we try to understand microservice concepts first. So we need to, when we want to learn microservices, we need to know why actually we need to learn microservices, why microservices is grabbing this much market in nowadays, what are the benefits, all this stuff we are going to discuss. And we are also going to look at each of the benefit with an example lab session. At the same time, we do have some challenges implementing microservices. Every architecture generally will have some. Three-tier architecture has some drawbacks, two-tier architecture has some drawbacks. Microservice similarly has some challenges, more than drawbacks, I would say challenges. So drawback is something, from my view, I would see like, something which cannot be resolved, an issue which cannot be resolved. Challenge is something, the way I would see it is, something that can be fixed, maybe with little bit effort. So those kind of challenges we have in microservices, we'll just try to understand what are the challenges and how you can fix them. So then we'll be jumping onto the basic Java based microservices development using Spring Boot. So Spring Boot is basically, most of 90% of Java people who develop microservices, they use Spring Boot. So Spring Boot definitely we are going to cover very in depth, Srinivas, for your question. So Spring Boot will be our first lab, in fact. So we'll start our labs with Spring Boot, learning Spring Boot, because most of the example that we are going to see, most of the labs that we are going to execute are based on Spring Boot. So Spring Boot basically, it is more widely used for microservices development in Java. So Spring Boot definitely we need to understand in depth, and there are many different numbers of features in Spring Boot which will help to manage microservice architecture. So we need to learn them as well. So different Spring Boot features, maybe you will see actuator, Spring Boot monitoring, all that stuff. We are definitely going to cover that. So we'll start our labs with Spring Boot. Or when I say labs, of course we'll discuss concepts as well. We'll discuss concepts first. We'll try to understand the basics of each and every topic. Then we'll jump onto the lab so that we'll get more detailed understanding along with some programming knowledge on the topics we discuss. So after understanding on the microservices definition, microservices concept, microservices architecture, benefits, all this stuff, we'll jump onto the Spring Boot and we'll try to understand Spring Boot and we'll try to develop a Spring Boot program. And then there is something called Spring Initializer. So we are going to see it, what it is. So it's basically a project creation stuff. Using Spring Initializer, you'll be able to create a project, but with more, it will have more advanced options. So that it will reduce some, at least some level of configuration and some level of programming, I would say. So after starting with Spring Boot, we'll jump onto the Spring Initializer and we'll see. So what is the use of Spring Initializer? Then we are going to look at different important Spring Boot annotations. Then we are going to look at how we can develop REST services using Spring Boot. So what are the different annotations available in REST, in basic REST implementation, as well as specific Spring Boot annotations. Basically, you know, REST is a type of web service. Of course, we are going to discuss that. There are a couple of libraries available. JOXRS is something, Java library available. So JOXRS has specific set of annotations to develop a REST web service. At the same time, Spring Boot also has specific set of annotations. So we are going to compare, we are going to learn each of these annotations and we are going to compare these annotations and how one annotation is better than the other annotation, where actually different annotations fits. So we are going to learn Spring Boot annotations, REST annotations, and we are going to develop Spring Boot application as a REST controller, otherwise as a REST service. So a couple of REST topics we'll be able to cover there, we'll be covering there. Then we'll just try to develop actual microservice architecture, the complete architecture. What we have discussed so far is developing a single microservice, and we are going to see how actually it fits in the complete microservice architecture. What are the different things we'll be having in the architecture, and how we are going to develop or manage different things in our architecture. You'll understand this once you got a clear idea on microservice architecture, which we are going to, of course, discuss in very detailed way, the microservice architecture. Then we are going to talk on security, the microservices security overall, I would say. Basically, when security is discussed, there are generally three ways. At least in microservices architecture, I would say three. Most of the developers follow three different ways to implement security. One is OAuth authentication. The second one is, few people implement their own authentication. OAuth is, something like, a third party authentication kind of stuff. Of course, we are going to discuss. Then implementing our own authentication for security. Then there is something called JSON Web Token. So that also we are going to, these three types of authentication or securing microservices will discuss. After Spring Boot understanding or gaining some knowledge on Spring Boot, we'll jump onto the security, because security is It's always stands on very high requirement, right? So security is definitely something we need to understand very in detail. So how we can secure our microservice is something we are going to discuss in this training. So then we have something on maintaining data, Spring Data JPA. So because microservice is something which actually gives you a way of attaching different databases to different services. Earlier, in the early approach, basically the legacy approach, entire your application will generally have one database. All your data goes to that database, and you'll just store in one database. But here, microservices gives you freedom to have different many number of databases. So that's where you need to understand more advanced way of managing your data with some less coding and all. You might have already worked on some kind of ORM tools, object relational mapping tools, maybe Hibernate. So JPA, Java Persistence API, Hibernate. So similar to that, Spring Data JPA is something, an advanced version of JPA, I would say. It's basically persisting your data or mapping your objects to the database tables. So which plays an important role in microservices architecture again, because we have number of databases here. So you need not, you shouldn't end up writing more code to maintain different databases for different services. So that's why Spring Data JPA is something plays an important role here. So microservices patterns. Any example, Srinivas here? Microservices itself is an architecture. So you have anything in mind when you say pattern? You can just ping me on chat. I'll see. So after Spring Data JPA, so we are going to cover Spring Cloud, which again covers most of microservices related features. So we have discussed something like challenges, right? So when you adopt microservices architecture, some challenges comes into picture. So those challenges, to address those challenges, maybe I would say otherwise, Spring has recently come up with a different tool called Spring Cloud. It has different features where you can use them and solve your microservices challenges. So we're going to use those features, the Spring Cloud features, and we're going to see how we are fixing the challenges that we encounter in microservices. What are the challenges that we are going to understand? Then we are going to use Spring Cloud materials or Spring Cloud features, and we are going to fix those challenges. Spring Cloud is nowhere related to AWS, I would say. Spring Cloud is across cloud platforms. You can AWS is one of the cloud vendors, right? Amazon Web Services. So Spring Cloud actually works in PCF as well. Azure, Microsoft Azure, Google Cloud. So all these things. So AWS is different. It's not Spring Cloud is not specific to AWS. Otherwise, not specific to running your applications or microservices on AWS cloud or running your application on any cloud environment. So, but Spring Cloud is something which actually provides some features that helps you, to run your application easily on cloud. There may be a different challenges, right? So again, mostly I would say Spring Cloud addresses microservices challenges, and that too when running your microservices in the cloud environment. So not specific or tied to any particular cloud vendor like AWS or Azure or Google Cloud. So then after learning all this stuff, We may be looking at some individual examples when we are covering different topics like this. Maybe when covering Spring Cloud histories, we may be looking at an individual example. When covering Spring Boot, we may be looking at an individual example. But overall, our knowledge after this training should be refactoring a monolithic application or refactoring a legacy application to the microservices. So most of you might be already attended demo. So there I was actually saying 99% of current microservices requirement is clients already have a very big applications, or I would say monolithic applications, or I would say three-tier or two-tier applications, a legacy old environment or a legacy old architecture. So they already have applications. So and those applications became very much big that the clients are facing so much issues managing it. So now they want these monolithic applications to be refactored to microservices so that they can easily manage and they can adopt DevOps kind of style, DevOps environment. What's DevOps? Sorry, DevOps is basically, I would say, continuous development and continuous delivery, right? Or CI/CD, continuous integration as continuous delivery. So the changing requirement should be actually should go into production, continuously, without impacting your running existing application. So most of the current market's requirement is they have a monolithic application and they want to refactor it to microservices. So we are going to see with an example refactoring a monolithic application to microservices. So how actually a monolithic application was there, a very big application, otherwise a traditional three-tier application, an MVC application, MVC patterned, model view controller kind of an MVC patterned application. We are going to look at an example, and then we are going to split it into microservices, and we are going to run it as a different services. Maybe we are going to split the database as well, and we are going to understand what are the different factors that we need to be taking care when you are refactoring a monolithic application, a very big application to the microservices. How you start splitting it, how you start bringing out one by one services, how you identify what is the service that you need to bring out first, right? So those things will be generally discussing, so that in future, if you basically if you're going to work on microservices thing, this is what you're going to get, mostly monolithic to microservices refactoring. So that helps you in your real time work environment. So then we are going to talk about a little bit on Docker and running microservices in Docker as well, because Docker is again this container-based platforms again gaining more attention of the market. So we need to get that knowledge as well. So we're going to discuss what are the different things that we need to take care or we need to understand when you want to develop your microservices using containers. So we are going to understand a few Docker basics like what are the Docker images, what is Docker file, what you'll be having in Docker file. Basically, it's a configuration file, of course. We are going to see few Docker basics, and running a microservice in Docker container also we're going to see. And then something on microservices events. So this is one of the challenges again. You need to be basically aware of when you are developing microservices environment. This is something related to maintaining multiple databases. So how you maintain multiple databases when you are having multiple databases, how these databases will be in sync. Maybe one database is dependent on other database data. So when one database gets updated, maybe it requires another database also to be updated. All this stuff, data synchronization comes into picture. It would come into picture as a challenge. So there we are going to events is one of the ways to resolve the data synchronization. We are going to discuss that. So then we are also going to see how you want to deploy a microservices, cloud, and just for our real-time feel. We are going to deploy the developed microservices to any of cloud vendors. Mostly it's a Cloud Foundry I would prefer because it gives you a 1 month free access. Of course, AWS, Azure also they have their own free access, but PCF is something I would say again, uh, have more features when you adopt microservices technology. PCF have some special things for microservices, I would say. So that's the reason I'm again, I'm seeing most of the clients when they are adopting microservices environment, right? So they are choosing PCF also because they know PCF has some additional features compared to other cloud vendors to deploy microservices. So the clients want to enjoy those features as well, developed by, given by PCF. That's where, in most of the, as per my experience for last 4 to 5 years, I've seen different clients and, discussing with different other microservices trainers, all that stuff. And of course, going through a number of papers, all these things. So I'm seeing most of the, microservices adoption actually they're leading to PCF deployment. So that's where I wanted to just see, or I wanted you to learn how you can deploy microservices in PCF using, it's some special features of PCF for microservices. So we're going to see that. So overall, that is the thing. So that actually ends our training. So overall, we are going to learn microservices concepts. Then we are going to learn Spring Boot, then Spring Cloud. After that, security, microservices security, then Spring Data JPA as well, then Docker, and mostly refactoring monolith to microservice. These are the things. So we're going to learn, and that what is Docker? So I have a question from Srinivasra. What is Docker? I would give you a brief definition, but we need to see it in when we are discussing really the Docker session. Docker is a container, basically, a container kind of. I'm not sure if you know what a container is. So container is a concept where you just you may be knowing at least VM, virtual machine. So similar to virtual machine, container is maybe I would say an advanced concept of virtual machine. Otherwise, both are basically rivalries. So container says like it has its own. Each container will have its own kernel or its own operating right from the operating system to every different technology that is required to run an application. It will be having, there won't be a sharing of operating system. So VM is where multiple VMs can share a common OS, but container is different. Each container will has a separate OS that has its own again advantages. Of course, we are going to see in depth when we discuss about Docker. For now, you can assume a container as a VM kind of stuff, virtual machines, right? So where you already have some experience running applications. So basically, when you complete developing an application, basically you push your application into any of VM server or Linux server, basically, and run your application, right? Similar to that, container is something where you can run your applications, but it has a different technology, I would say, right? So that's Docker brief definition. So these are the topics that we are going to cover as part of this training. If anything comes, mostly I want this topic to be more interactive. You can actually talk. You need not chat every time, right? So we can because we have allotted pretty much good number of hours for this. We are planning at least 60 hours of session so that we have pretty much good time for all the discussions, all the questions, many different lab sessions. If anything required, any new concept required, we want to have some space for that also. So that's where we can talk, we can discuss as much time as required. So you can just keep talking. If not now, at least if not when discussing the concept, at least when doing the labs, right? Okay. So having said that, or having looked at the different number of topics that we are going to learn as part of this training, let's start up with the simple introduction to microservices. What is microservice, Noel? Yeah, so we are just going to start that, Mithun. So there's a question. So we have not yet talked about that. What's a microservice? So all we discussed is, we are what we are going to learn. So what I said is we are going to learn this microservice architecture, some Spring related technologies to develop microservices. But now let's understand what's a microservices. So let's try to look at a definition from a world famous developer here, Martin Fowler. So he's a very senior developer, and as per his definition, so microservice is basically an architectural style. Basically, it's an architecture. So when we talk about architecture, what are the different software architectures we have currently? Maybe you people knowing as a Java developer, maybe you know a three-tier architecture, or maybe a MVC architecture, model view controller, which is nothing but again three-tiered. Sometimes entire architecture also there. Entire architecture is something again related to three-tier architecture, but you'll have more number of services. What is actually an architecture here is, I would say, maybe a style of development. So when you stick to an architecture, you'll just try to develop an application by following that particular style. A three-tier architecture style ask you to develop your application in three different layers, right? General three-tier architecture, a legacy architecture. So you guys might have already developed some applications, or some of you guys might be into supporting or might be into maintenance. But end of the day, you might be maintaining some Java application, right? So that application in a legacy way, from the beginning, the software is evolved from one tier to two tier to three tier. So three tier is or MVC pattern or three tier. Generally three tier. MVC is again, something different. So most of the current markets applications, the software up, right? Is there a question?
Okay. Ramesh, is so also architecture, right?
Yeah. So as also an architecture. That's somewhere in between. I would say legacy, then SOA, then microservices. We are going to look at SOA also,
Okay.
right? So let's understand from three-tier architecture, as most of you guys may be knowing three-tier architecture. So when you follow three-tier architecture for developing an application, what a three-tier architecture asks you? It asks you to develop your application in three different layers. What are those layers? It will ask you to put all your business logic into one layer, otherwise one bundle, right? One bundle of code. So all the business logic. So what is the business logic? Maybe for simplicity, let's assume a calculator application. So you may want to write a method for adding two numbers. So there you may end up, you may be writing a method, creating a method, and in the method you may be writing a statement like, maybe written, I plus j, which may be two variables, two input variables, or two method parameters. This is some business logic, right? A very simple business logic. These kind of logics may be, there may be number of different methods like this, we're actually doing some calculations, or maybe looking for all the customers who actually purchased some stuff today, or maybe another business logic, maybe all the customers who actually logged in. You may want to send a report end of the day, what are the different numbers as per your client requirement. Maybe a different business logic, maybe, or the different products purchased today, like this, right? Maybe a customer when placed an order, some way something needs to be taken place in the background, right? Maybe some database creation, database record creation, right? When customer clicks on the purchase, but there you will again, write some method. End of the day, you will write some method in a class. You'll create a method, and if it is a purchase, Maybe you'll create a purchase record in your database so that from there another things will take place so that the customer will be delivered, the product will be delivered to the customer. So these are all business logics. So all your business logic into one as part of maybe one bundle, one package, it will ask. And all the presentation layer, so which is actually maybe the actual content that customer sees, maybe the website, the UI pages, the JSP pages, the HTMLs, all this stuff, right? So presentation layer, it asks for separate layer. Business layer, again, all the business logic. Then something called data layer where you will be, maybe your database. So this is how it asks, right? When you follow three-tier architecture, a legacy architecture. But whatever maybe there may be hundreds of business logics, maybe there may be hundreds of different methods. You all keep them into one bundle, right? Maybe one var file, one jar file. How do you run your Java application? You'll keep writing all the Java classes. Out of Java classes, you will be deriving one jar file, Java archive, and you may be putting this jar file in maybe any of your servers. The jar file generally contains your class files, right? So maybe once you put this jar file or the var file into your server, that server will just take care based on your maybe front end servlet configuration, all this stuff, right? So you may be having some front controller, all these things. But any number of business logics, maybe it's a purchase or it's a customer record deletion, or maybe adding a new customer, adding a new product, right? Adding a new order, whatever the number of business logic, you all gonna keep that into one layer, which we are calling as business layer. And that's how the three-tier architecture explains you developing an application. Similar to that, microservices are also an architecture, but it tells you developing in a different way. What is that way is, so basically it's an architecture, and that architecture tells you to develop your application as a suite of small services. Three-tier architecture tells you to develop your application as three different layers. Microservices architecture tells you to develop your application as three different as different services, as number of small services, instead of developing it as a big single application, maybe a big single business layer, right? So that's how you develop in three-tier. What microservices architecture tells you to develop your application as a suite of small services, a number of small tiny services it asks you to develop. Similar, maybe similar product, similar purchasing thing, we take it, or e-commerce thing, generally we call it as e-commerce, right? Online marketing or online purchase, online business, e-commerce. So if you follow three-tier architecture, you may be developing in one way. If you follow microservices architecture, you will end up developing in a different way. If you follow three-tier architecture, maybe you'll put all business logic into one single bundle, or one single package, or one single project. Let's understand. Let's take it as a single project. So all whatever the as we just said, couple of business logic, you know, confirm a purchase, add a user, remove a user, add a product, all this stuff you'll develop as one single project. But whereas the microservices architecture tells you to separate your business logic also as per the bounded context. Bounded context is a different term here, so we'll try to understand bounded context. But separate your, if required, you separate your business logic as well, but make sure you're not developing your application as a single big application, but you are developing your application as number of services. How many number of services, how do you divide your service is something you're gonna learn. There are some standards mentioned. If you follow those standards, you will just derive a service and all the business logic which goes into that service. So instead of developing a single big project for your application, you're going to develop multiple projects, multiple small projects. So it tells you to develop your application as a suite of small services, and also each service should run as separate process. And of course, when you develop your application as multiple services, there will be a requirement of communication between the services. So we just again, e-commerce thing we were discussing. If you want to, maybe let's say as per the microservices architecture, now you developing customer as a separate project. So all the customer related business logic goes into customer project. What is a customer related business logic? Maybe adding a new customer, removing an existing customer, adding some points to the customer, reward points, let's say. E-commerce example only we keep discussing so that everyone, maybe that's an easy example that everyone can get aligned to. These are the different customer related business logic, right? So this is no way related to purchasing and maybe adding product, all this stuff, adding reward points to the customer, or right, updating a customer address, updating a customer phone number, all this stuff. But here I just said adding reward points to the customer. So how do you add? There may be a logic to see all the different orders made by the customer. So based on the number of orders, you may be deciding the reward points. So there, all the orders now you, as per the microservice architecture, you start developing in a separate project. You are running it as a separate project. So now you want to see the number of orders placed by this customer. So this customer service and order service should be communicating. Of course, similar stuff exists in three-tier architecture as well. There it will be just a method call. Maybe you will have a customer Java package and then customer related Java classes, customer DAO, right? Or customer interface, then customer class, all this stuff. In the customer DAO, you may be having adding customer, removing customer, all these methods. So in general, in a three-tier architecture, it would be a method call. But how do you communicate when you are running these two as a separate projects? In the three-tier, we are running it as a single project. So when it is a single project, all are nothing but adjacent Java classes, right? Some Java class in a different package, but in the same package. Sorry, but in the same project. So there it will be just a method call from one package to other package. You'll just import that package. You'll import order service, and you will just you'll just call for number of orders by that customer. Maybe order class will have that related method, and it will just reply. That's where the method call, all or method calls in three-tier architecture. But here it's altogether different projects running on different services. Then this communication, how we are going to do? Microservices architecture says definitely you need to implement some communication between these services. When you develop your application as a number of services, definitely you will be needing to communicate between the services. When you have that kind of a requirement, you need to make sure you are doing that communication in a lighter weight mechanism. What is lighter weight? We are going to understand. But for now, what is microservices? Microservices is on an architecture. What it is saying, if you are developing an application, don't develop it as a single big application, but rather develop it as a multiple number of services, whereas these services are running individually as a different processes, and they are able to communicate whenever required. So that means you need to take care of communication also. We don't have method calls now because you cannot just simply call a method from order project, because order project is running somewhere else somewhere in a different server. So that's where, so you'll just take care of communication between these services. And also these services are, each service is taking care of only one business capability, one business logic only. It should take care, one microservice to deal with a single business capability. What is business capability here? Maybe customer is a business capability here. So if you have a e-commerce application requirement, if your client has come and asked you to develop a software application where he can just use and sell his products, maybe you will think about maintaining all the customer records, all that stuff, adding a customer, all that stuff. So customer is a business capability. Maybe you'll think about maintaining customer products in your website. So product is a business capability here. So that way. So how you define a business capability? Again, define, depends on bounded context and other stuff we are going to discuss. But for now, we are taking care that each service deals with one business capability. Customer service doesn't need to understand how order should be placed, right? How order should be dispatched, all that stuff. Maybe how a new product should be ordered. So customer service need not worry about that. That is something comes into orders bucket. And also these services should be developed in a way that they are independently deployable. And also you should have some automated process to deploy that. So why you should have automated deployment, that we are going to discuss. So we already crossed 2 minutes to 8:30. But for now, so what is independently deployable here is, that also we need some explanation, but in a shorter way. Let's say you have developed now, instead of creating different packages in one project as in a legacy way, to develop a customer project, maybe one team is working on customer. Of course they get the same project, they'll clone the same project, otherwise they'll check out the same project, but maybe one. Is there a question? Okay, so just give me 2 more minutes. We are going to complete this. I know you'll have your own schedules. So in 2 minutes, let's just to, as this is the first session, we'll make 5 minutes or 10 minutes as what do you call, maybe a turnaround time kind of stuff, right? So for now, this is in today. What we learned is microservices is an architecture, and that architecture tells you to develop your application as number of different services, and also take care of their communication. Take care that they are developed in a such a way that they can be independently deployable. Customer to deploy. Let's say you have worked, you have completed customer development, customer project deployment. You need not wait for orders team or for purchase for products team to complete their work. You would be able to deploy customer independently without worrying. There shouldn't be a, when you're deploying, there shouldn't be a call to the order and say, hey, order, I'm unable to reach order, so I cannot deploy this customer as well. Just make sure orders is also up. So these kind of stuff shouldn't be there. In three-tier architecture, you may be facing this. Let's say, in orders Java class, there is a incorrect method, some compile time error, that will stop you deploying customer classes as well, because all customer classes, product classes, order classes into same bundle. Compilation error in one order bundle or order package will stop deploying customer package as well as product package, right? So that kind of stuff shouldn't be there in microservices. Independently deployable is something explains this, right? So we're going to see more on that. So that's why I've taken this definition is, this definition basically contains most of the core concepts of microservices concept. So microservices, this is what, developing an application as number of services, independently deployable, communicating in a lighter weight. So this is how we are going to do this. We are going to see. So maybe if you will park it here. So we'll again continue this discussion tomorrow the same time, 7:30. And I forgot to ask, just give me 1 more minute. So 7:30 to 8:30 is what we planned. I hope that is planned after following up with you by Visualpath. If there is any time change that you want, maybe you can just post on the chat, maybe 7 to 8 or 8 to 9. If that is the case, let's fix it in the beginning itself, so that later you won't be able to struggle with this timing. You can just advise me. If not now, maybe tomorrow during the beginning, 7:30 to 8:30. If you can fix, daily we are going to meet at sharp 7:30, and we are going to start the conversation by 7:33, right? So, okay, guys, so that's it for today. So, mostly, as I said, this would be a introductory session. So, mostly, today we learned what is your knowledge and what kind of knowledge you are going to gain out of this training. And we started with microservices definition. That's it. We'll just keep continuing tomorrow. Thanks everyone for joining. Have a nice day.